Hello, welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group to help people get stuck into Python and really get started in it from a beginner's point of view. It's got quite a lot of information about Python out there, and some of it is information that doesn't really help. So hopefully this will get you into it. Now, on the first week of the month, we try to cater for absolute beginners, and then on other weeks we can look at slightly more advanced topics. And today we're going to be looking at Plotly, a way of doing data visualization in Python. But feel free to ask any questions that you want, including how to just really get started in Python. We're going to be using Google Colab mostly tonight, so it's you don't need to install Python on your computer, and the Python that comes with Google Colab's quite recent. They give you a virtual private server to run for free, so that's the one I recommend. If you want to save anything, you'll need your own Google account, but that's about it. So if you want to send questions, you can send questions to Slack. Get rid of that. Will that come up? In the Learning to Code channel of Beginners Python and Machine Learning. You can also send it to the YouTube chat as well if you haven't got a Slack account set up. There's instructions down below this video. It tells you how to get your Slack account if you want to talk to us, and that's good if you want to ask questions between sessions. And other people will give you help as well if I can't. All right, so we've got a question already. Please explain a few lines of code or as much as possible in the time frame. Okay, well, let's give it a go. So below the video I've got a link here to our Google Colab notebook, so click on that link and that will open up a new probably open in a new window for you, because otherwise you won't be able to watch the video. And there's the links. So as I'm giving descriptions, especially Ashok, as you've asked, just tell me if I'm going into enough detail, or you want to, if you want me to give in more details. Okay, so we've got a few links here. This is the link to the file that you're in. There's the YouTube video, the meetup that you've got registered, but also this the GitHub site. And the GitHub site, we've got all our past sessions, and the sessions have got all these links. So if you want to find an old YouTube link or an old Colab link, you go into that GitHub session and you'll find all the sessions that I've done. All right, so we're going to be using Plotly. Okay, first of all, Google Colab, you want to do a copy to drive, and that way you'll be able to make changes and save your changes to your area, and I'm going to do that as well, so that starting just like you, I'm using an account that's different to the account that created the Colab notebook, so it'll all look the same. See, it says here copy of now meetup 222. That means we're working on the copy, and we can click on connect, and that'll start the connection happening. So that's going to fire up a virtual private server from Google, and you can see they've given us some RAM, 12.67 gigabytes of RAM and 107 gigabytes of disk storage, of which we're just using a little bit of it at the moment. In the Colab notebook, you'll see it's made up of cells. I think they've just changed the look of it a bit. So this is a text cell. It's got formatted text in. We've got a nice heading here and an unordered list and a few links. And then these other cells are Python code cells. And you can add extra cells. See, if I hover in between the two, I can add a code cell or a text cell. at any time. And I'd recommend, as we're going through and you want to try something out, just add in another code cell and type in some code and see if it does what you expect it to do. That's a really good way of learning. So these Python commands here, so they start with a hash symbol, and that means it's a comment, and Google Colab has very kindly done some syntax coloring for us so that the comments are all in green. But sometimes we want to run a command that is using the underlying operating system on Google Colab. There's a couple of ways of doing that. One is in the Python cell, if you start the line with an exclamation mark, it'll assume that you're running it from the command line. And for just single things, that's single commands, that's probably the easiest one to do. The other way, you see down the bottom here, there's now a terminal link. This used to be a paid for feature, but now it's free, so all of the free users get access to terminal as well. But anyway, we're just we want to see which library of Plotly is currently installed. So we're going to use the Python program pip, which is a command line program, to list all the currently installed third-party libraries, and then we're going to send it through this pipe filter, which is just going to look for all the ones that have got the word. So grep means just filter ones using regular expressions with the word Plotly. So if I run that, it'll tell me that we've got Plotly installed as one of the third-party libraries. That's what pip told me, and if I didn't put that filter on, there'd be a whole bunch of other things coming up as well, but this is the only one with Plotly in it, and it's version 5.24.1. Now, some of the syntax I've used later requires version 6.0, and so we need to upgrade that. So to upgrade it, we can just run once again the command line pip install and -- upgrade Plotly, and that'll go off to Pippy, and it will pull down the wheel. That's what where the installer is, and any dependencies. So it's depending on narwhals and packaging, but they're already satisfied. It doesn't need more recent versions of those. So then it installs it. It takes the existing installation out and puts the new installation in, and now we're running 6.3. So if I go back to this top cell and run that again, you'll see that we're now running, we've now got Plotly 6.3.0 installed. Now if you tried to do that after you've been using it, it'll tell you that you need to restart your runtime to take advantage of the new library that you've installed. But because it was the first thing we did, we don't need to do that. Now in Python, when you want to use third-party libraries or even standard libraries that aren't built in, you have to import them. So we just say which libraries we're going to use, and it's really, the purpose of that is just, they call it namespace, so that it just means that if you've got two libraries that have got the same function names or class names, then you just import the ones that you want so that they're unlikely to clash, and even if they do clash, then you can just use these the library names to get around any clashes. So for example, graph objects from Plotly, we're going to import just as GO, so it's really easy to type. We're going to import pandas just as PD, so that's really easy to type. And so it's just to get around the potential problem. Two different people writing third-party libraries have used the same names for something. All right, so I better run that, and you can see the number 4 comes up here, so it's the 4th cell that I've run. Okay, so let's have a look at Plotly, and I've given you some links here to the Plotly site, which could give you more information about what we're doing. Now Plotly is a bunch of, it's a Python library. It lets you assemble data and then send it off to a web page, and they look really nice. So let's just run it first so we can see what we're going to get. So this is a Plotly chart. It's comes up in HTML, but it's got a lot of JavaScript behind it. In fact, most of Plotly is written in JavaScript. And all we're doing from Python is just assembling our data in a particular way and then sending it as JSON to the Plotly JavaScript library. And from there, it does all the work of rendering it. And it comes with all these fantastic tools, like you can zoom in on particular parts. So I've got the zoom button selected, and I can just drag a rectangle like that, and it zooms in, so I can have a look in a lot of detail at the data in my chart. So it's great for visualization. I'll just reset that. I can also pan, so if something's off the screen, I can move it around until it comes onto the screen. So that's really nice. You can select things, zoom in, zoom out. You can even download the plot as a PNG if you want to put it in a report or something like that. Okay, so let's have a look at how we created that. So this is using the very low level way of using Plotly. I'm just creating a dictionary, and then I'm passing it to Plotly, and Plotly sends it off to the JavaScript library to be used. And so in my dictionary, I've just got two elements. I've got a data element that is a list of pieces of data. So say I wanted it in a scattered chart. This is my X data, this is my Y data, and I'm going to call it up down. And you can see up down's come up here on the legend. And then I've got another one which is going to be called climber, because the data is just always climbing, going up, and so that's the red one called climber. Now this show that only works in Google Colab, and so it's detected that we're running Colab, and it can give us this interactive chart inside our web page. But sometimes you're not using Google Colab, in which case you can use this write HTML function, and that will create an HTML file called figure1.html. And it actually has saved this into the virtual private server at Google Colab, and I can look at the files. If I click on this folder over here on the left, and I can see that there's now a file here called figure1.html that's been created. So we can have a look at what that file is like. If I download that, that's saved it down into a folder. Let's have a look. I've got a couple other things in the download folder, but here we go. Figure 1. It's 4.6 megabytes, and it's a HTML document. So let's try opening that. And there it is. It looks like pretty similar to what we saw in Google Colab. So if I press F12, I can see what the construction of it is. I've got a div here. We've got a little bit of a script here that is in JavaScript, is just starting off what we've got. And then here, this next one, the script tag, is all of Plotly version 3.1. And it goes down to here, it goes, it's got all this code here, and then it goes ... And I think they've, in our development view here, that's where your 4.6 megabytes of page content is. It's all in that element, and so they've decided not to show it all. They've just gone ... But that is all of Plotly, all hidden in that one script tag. And then if we look at our div tag, we'll see that we've got the different parts. So somewhere in there is our data. I've actually made the data, here we go, I made this a fairly unique number, 2.5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I should be able to search on it and find out where that is. 2.5, 1, 2, 3, 4, 5, 6. There we go. So we can see that's in our script in JavaScript, and it's got our data. So it looks very similar to the Python dictionary that we created, and it's converted it to a JSON object. And so now you can see what Plotly has done. And I'm getting a few questions here, so I better read these. What are you doing, sir? What I'm doing is I'm showing you how Plotly is working, which is a Python program that is sending a JSON object to some JavaScript in the Plotly library. And by knowing how it works this way, it'll help you if you need to do things more complicated than the straightforward Plotly at a later stage. Scott's asked, can you still zoom? And you can. Here you can see I can still zoom in once it's on a web page, and that's because it's all based on JavaScript. Once you download the plot as a PNG file, then you can no longer zoom it. It's just a straight PNG snapshot of what you're looking at. All right. Okay, so that's all good. So that's how Plotly is working. Now let's see how we use it to make what we want. And I've put here a challenge so you can have a go at doing this yourself. Given the following lists of x and y values, which represent the sigmoid function, plot the values in a scatter chart using a dictionary to create them. And if I run this cell, you can see I've got a set of x's, which is going -10, -9, -8, and some values of y. And y is just 1 over 1 plus e to the minus x. So that's the sigmoid function. When you're doing machine learning, that's a function that you will need in some of the things you want to do. So it's nice to have a visual of what that function actually looks like. Okay. So let's just copy some of this and we'll paste it here. So what we're saying, we want the data we're going to have is x, and we're going to have some y data, which we've stored in a variable called y. That's even easier. And the name, we can just call it sigmoid. We've only got one set of data, so let's delete the second set of data, and we'll just make a title here. Okay, and we'll run that. And there we go, there's our chart, sigmoid chart constructed as a dictionary. So you can see we've taken some x's and we've taken some y's and plotting them all on the chart. No legend showed up because there was only one set of data there, where we get all the functionality with zooming, panning, and scaling, resetting, and downloading PNGs. So like when I started using this, I'm used to providing data as XY pairs, but Plotly likes to give the data as all the X's and then all the Y's, and it matches them up later. So that's fine once you get used to it. All right, so how'd you go with that that challenge? Did you manage to get that one out? So here's the solution to challenge 1, and I've just added a bit more information in there. If you're only showing one item in the data list, you need to explicitly show the legend. So you can see this is an extra parameter that I've put into the dictionary, show legend equals true, and that's about the only difference. You can see that it's just a series of line segments, so they're straight lines, so it's a bit jagged in places. If you wanted to, you could get more more data points. So I've used the NumPy function linspace to give me 21 data points in here, but I could have easily said give me 41 data points. Then when I've calculated my y, this is a nice feature out of NumPy. I can use a whole array as the argument of this function, and it will return an array with different values in it. So now I've got a lot more values. So this is linspace is just a linearly split up. I've got 41 different values, and they're all equally spaced, so going up in 0.5s. And now if I plot my chart, you'll find it's just a bit smoother. And let's get rid of this. Now Plotly likes to abstract you away from that bare bones just creating a dictionary and hoping that you get everything in the right place. So they've got this higher level that you can go to called graph objects, and from graph objects then you can create a figure with providing in the data. And the advantage of doing it this way is that you now get some built-in validation that'll tell you if you've used a bad parameter name or something. So let's run this, and you can see that Go figure is it works. Now if we misnamed one of these, like I just called it YY, it will give me this error message and say these are the parameters that you should be using. There's quite a lot of them, and YY is not one of them. So I go, okay, I'll fix that up and call it Y. Now once I've created my figure, then it's got these methods on the figure that I can call. One is write HTML, which is a bit like the previous one we did, which will save an HTML file. And if we look over here, we can see figure2.html has been saved. But it's also got the show method. So we can just say show my figure, fig.show. And there's our bar chart that we've created. So the first time we created a scatter chart, this time we created a bar chart. If you want to see how it's the figure by doing it this way, the dictionary that it got created, and you can see by printing fig, it's saying this is the dictionary that it's really put together by the data we've given it. It looks pretty similar to what we did before. It's just got this template in there. The template's all just boilerplate code, so it's even just decided not to even show it to us. If you want to see it, you can use the toDict method on the figure, and you'll see the full one. You can see all this stuff here is all part of the template. Okay, challenge 2, using X and Y from challenge 1, plot the value using graph objects. So once again, I like to copy and paste. And we'll just so I'm going to create my figure, the data. We're going to use a bar. Well, why don't we use a scatter again? The X values we've stored in a variable called X. So I'll say X equals X. The Y values we've stored in a variable called Y, and your variable could be called anything you like, but we've decided to call it Y, and it'll be sigmoid. You see now show legend equals true. That's how we specify when to show the legend, and let's call it that. We don't need to create an HTML file, we just need to show it. and there it is, sigmoid chart constructed using graph objects, and it's a bit smoother too because we've used the 41 data points. Okay, so here's my solution to challenge 2, and I'm going to throw in a bit of extra information as well. For the mode, by default that was lines, but we can change the mode to lines and markers, and we can change the marker symbol to hash dot. And we can make it a width of 1 pixel, or 1 in their scale sizing system, and a marker size of 15. So let's run that. Prints out what the dictionary looks like that would have created. So we could have actually just created this using that dictionary if we needed to. But here is our sigmoid function, and you can see it's got lines, which is the blue, it's got the markers, which is the black hashes, and the style of them is hash dot, so it's a hash symbol with a black dot in the middle. You probably can't see it on my screen, but if you run it on your screen you should be able to see the dot in the middle of the hash. And it's got a legend and a title. And you get all the things like zooming and panning as we had before. All right, so what I like to do, this is really taken from an example at plotly.com/python/marker style, is have a look at all the different types of markers that you can put on your charts if you like. And this is the code. This is the one bit of code that didn't work with version 5 of Plotly. So that's why we need version 6. And it seems that this is the bit of code that changes the most going from version to version, which is funny because it's a bit of code that hardly anyone would use. But it's good for this exercise. What we're trying to do is find all the different symbols that are available. Yeah. So this is what, if I ask for all the raw symbols, I get a number in a text, a description of the symbol, so it could be circle or circle open or circle with a dot, and then this number, I don't know what that means. Oh, that's the next number. So this is the ID. The ID is a string. The name, which is the name stem, and the name variant. So for example, that's the name stem, that's the name variant, and then the next one, it goes on and gives you the next slot. So each set of 3 values is in the symbols. All right, challenge 3, assemble the data into tuples. That's like this: int ID, string ID, name stem, name variant. Okay, so what we want to do, we want to loop through all the data and get it one at a time. Well, so 3 at a time to make it the tuple, and then we go to convert the stem and the variant. So this is just Python coding that we're going to be doing now. Not really much to do with Plotly, but it's useful to be able to do this sort of stuff. So we'll create a list that we're going to put them in, and then we're going to loop through all the oh yeah, right, and the AI has come to the rescue, and it's also looked ahead a bit, probably looking at my answer to see how I would do it. So I won't do it exactly as they've done it, but I'll, okay, what does it do? Tab accepts it. So let's have a look at what we're doing here. So we're creating a range for I. So I is just going to count through all the symbols from 0 up to the length of them, and it's going to go up in threes. So the first time I is going to be 0, then the second time I is going to be 1, and then 2, and then 3, and that way we'll have an index to the start of each group of 3 that we want. Now int ID is just going to be our raw symbols I. So that's the ID of the symbol as an integer. We'll have a string ID is going to be the ID of the symbol as a string, and then our name is going to be the third element. So that's going to be made up of the name stem and the name variant. Now we want to split those two up. So just think of how we could do that. Like we could look for whether there's a dash in it. So we say if there's a dash in name, then we can name stem equal and it's trying to beat me. Sorry. So name stem equals, and I just want everything up into the dash. So let's go name, and we'll slice it everything up to the index of the dash, and the name variant is everything from the dash onwards. Otherwise the name stem is just the name and the name variant is empty. And then once I've got that, I've got the 4 pieces of data that I need for my tuple, and I can append it to my list. So let's just try this for the first few. Let's 15 we'll go, and we'll run that, and we'll have a look at what's in list. So in interactive Python, I can just put the variable name and it'll show me what's in it. So here we go. We've got 0, 0, circle, and no variant. We've got 100, 100, circle, and dash open, 200, 200, circle, and dash dot, and then circle and dash open dot, and then square and nothing. All right, so that's just a bit of Python code. That's one way of doing it. Here's the solution, which is, I've deliberately did it a slightly different way, so you can see different ways of doing the same thing in Python, and you can decide which one is going to, which way you like the best. You know, sometimes the longer way is easier to understand, but sometimes the shorter one is, because it's more succinct, it's easier to get your head around everything that's going on. So this has used things like, I can put 3 variables on the left of an equal sign and 3 values on the right hand side, and it assigns those 3 values to those 3 variables. That's not something you see in other programming languages, so it's a nice thing that Python can do. Name stem, we can just use the replace to get rid of everything after the name, and so that'll give us the stem, and then the variant will be everything after that. So we just look at the length of what's the stem and use this slice. So colon is a slice for a string, and anything before is where you're starting from, and anything after is how far you're going, and if you don't specify how far you're going, it takes it to the end of the string. And here's an alternative way using indexes, which is what I basically did. Then we append it to our list, and then we get the final. So you see it comes up with the same answer that we did. All right, sort the list of tuples by name. Once again, this is a data science. You need to be able to do some of this data manipulation. And how would you sort these? So the name is going to be in the indexed to value of each of these tuples. So we can define a function, we'll call it index2 of a tuple t, and it returns the second index for it. So now we've got that function, we can, there we go, we just use sorted. We can run sorted on our group of symbols using the key equals index2. And what does that give us? So you can see now they're all in alphabetical order. So that's a pretty quick way of sorting them. Now, because we had to define a function here, it took 2 lines, and then we could put it in here into our third line. In Python, there's also the lambda way of defining a function, which is just on this t colon t2. It'll have the same effect as those 3 lines, but it'll just do it all in 1 line. So if you're ever confused about what lambda does, it just creates a 1-line definition of a function that's got 1 parameter. So that creates all our group symbols. Then it's going to take the third item, make that all the variants, all the symbols, all the stems, and then all the full names of the symbols, and it's also going to take the IDs. So we're just doing data manipulation here. So now draw a scatter graph of these symbols. Now I might just go straight to the answer here. We're going to use our graph objects figure. So we create a figure by saying graph object figure and open parentheses, and we give it all the traces that we want. So first of all, we want to have a scatter. It's going to be showing markers. The X's are going to be the names of the variants. So that's nothing, open, I can't think of the others. And then the stems, and let's just look at it because you're not going to understand this by me describing it to you. And so here we go. We've got these are all the different markers, and it's just plotted them. They're the variants, dash open, dash dot, and dash open dot. So you can see an open one is, this is the normal one, this is the open one, this is the one with a dot in the middle, and this is one which is open with a dot. We've got additional features to this chart. So just think these are features that you can put in your own chart, but they've used the charting features to actually create a table with a graphical table. It's got hovering over it, so we can hover over different parts and get different details. So that's all very nice. And you've also got your zoom things just like we had before. And you can see we've got the grid that we've been drawn in as well. So in the marker line colors, midnight blue, marker colors, and there's your hover template, which is just some HTML to give you the Y value, the X value, a line break, and then the number. That was the name, and then the number is the symbol name. And so you can see what that looks like. Okay, so what we've done so far, we've looked at sending a dictionary to converting it to JSON and sending it off to JavaScript, and that drawed the chart. Or we've used the graph objects, which is a bit higher level. It gives us some error checking. Now there's another library called Plotly Express, also by the Plotly people, which is a higher level API again, and that's designed to work in conjunction with pandas DataFrames. So if you're using pandas DataFrames, then this Plotly Express can be a great way of doing it. So I can create a data frame here. So this is just pandas to create my 2 data frames, and then I can concatenate those data frames into a single data frame, and then I can send that off to Plotly Express, which we've abbreviated to PX. I remember when we imported it, Plotly Express, we imported as PX. So now it's just px.line. So we want a line chart using our data frame. We want to get the x's from our ID names in our data frame, and the y values are going to come from our scores in our data frame, and the colors are going to be from the groups. So I've printed the data frame so you can see what it looks like. The groups are up, down, or climber, climber, climber. And they show up in the legend now. And this is how the Plotly draws that just straight off the data frame. So if you've got your data in data frames, then Plotly Express is a great way of doing it, because you then it can handle the data frame quite easily, and you don't have to get your head around all the different parameters that you need to create even your figure objects. It's even put titles on the axes, a score title and an ID title. Okay, using X and Y from challenge 1, plot the values using Plotly Express. So you need to know how to create a data frame. So if I have my data frame equals, and AI is going to tell me how to create a data frame. The data is going to be my Y values, my index is going to be my X values, column is going to be sigmoid. Okay, I don't, I'll leave this FN out, because that's not part of what we were doing before. So let's have a look at the head. So this is our data frame. There's our X values and our Y values, so that's looking pretty good. So using X and Y from challenge 1, plot the values using Plotly Express. So the next thing, now we've got our data frame, we can just use px.line. Of the data frame, the X is going to be just the index. So we don't even need to say anything for the X, because it's just the index. Y is going to be this column here, sigmoid. And the color is, we won't have a color. And there we go. That was pretty easy to plot. Now in the solution, we wanted to have a legend as well. So we added a column called FN and put sigmoid in every value, and then that way we could group them into, use them in the legend. And so here we've got the function is sigmoid, and it shows up in the legend. Plotly Express comes with some default data sets if you want to practice, so you don't have to keep creating all your own data frames. So for example, you can get a data frame called Gapminder, which is, I think, looking at the gap in life expectancies. Life expectancy. So that's showing the difference between Australia and New Zealand for life expectancy. So Australia's got a slightly higher life expectancy, 81 versus 80. There's some details about the data frame that it changed. It's just sample data, so I don't need to go into that. There's some other nice ones. You might have noticed the Sankey chart I showed at the in the meetup image, and this is how you'd construct that. So this is showing where your personal income taxes are going. So if we run that, we've got our average personal income tax, so it's 10,000 say, and we've got some of it going to welfare, and then the welfare stuff is split up between age, disability and families, and then the rest of it you've got health, defence, education, etc. Now this is a pretty nice little chart. You can specify where you want these groups to be showing on the chart, but even if you're looking at it later, you just go, well, actually I want to see a bit more about that, and health, I want to rearrange it down to the bottom here and have that showing down here, and immigration, let's put that up here. So it's just amazing what they've got going in this the JavaScript that's going along behind the scenes to draw these. You can also do 3D surfaces, and I'll give you a link here to where that comes. They're really just fascinating to watch, look at, and because it's all interactive in JavaScript, I can put the mouse on it, grab it, move it around, and have a look at my data from all angles, which can be useful if I, trying to work out something about it, or trying to see some sort of odd aberration in the data. All right, so here, look at this comments. Notice how surface count equals 3. Okay, so let's go back to how we created this. And we created it, one of the parameters in figure was surface count, and so we called that a value 3. But when we print out the dictionary that gets made from it, we'll see that that gets split up into surface, and inside that is a dictionary called count, and inside that is 3. So this is what Plotly calls its magic underscore notation. It's just a Plotly specific feature, so don't try this in other Python. And every time they've got a underscore in a parameter name, it will do that sort of operation on it when it's arranging the dictionary. So this can be, I just zoomed in on there. This can be useful. That's the only one we've done there. Let's see if there's any more examples. Find another example that we have used. Okay, so what we're looking for is a parameter in a go.figure that has an underscore in it. You see here, value format, that's 2 words, but they haven't put an underscore in it, so that's not an example. And that's Plotly Express, so we're not talking about Plotly Express. Still Plotly Express. Alright, so here's some marker line color equals midnight blue. So there's some underscores there. So this is in figure 5. So if I create a new code cell here and print out figure 5, and I can remember what it was I was looking at, which was marker line color. See, I've got marker is here, and it's created this dictionary with color and line, and there's line, so marker line color is midnight blue. So it's probably easier to just type marker line color, but it's created this more complicated data structure by using that magic underscore notation. So do you understand what's going on there? Just really showing you a few things so when you come across them in Plotly, it's not a big surprise. And solution, look at solution 2, mark a line width was another one, and it came out like that. So some other examples here, title text, we could have done update layout with title text, or we can say update layout title text, and it has the same effect. And you'll see that there's the data layout title text. All right, now we're going to show you just a few of these ways of creating your data using NumPy. We've used the linear space one, I explained that. There's also a range. So there are two different ways of getting an equally spaced range. So you want to go from -10 to 10.1, going up in 0.5s. So a range excludes the final value, so it goes up to 10.0 but not 10.1. Linspace includes the final value, and this one we say the start and the finish, but then how many segments we want, so 41. So there's two ways of creating a space of linear space of X values. Now there's also another one called mgrid, which can be used, and it also is good for a two-dimensional set. But we'll just practice here with single dimensions. Just so like a range, you can say -10 to 10.1, going up in 0.5s, and that gives us the same data as a range did. Now we can also use mgrid like linspace, but they've done something it's quite amusing here. They want to keep using the word mgrid, but they want to somehow specify that that's going to be the number of elements we want, not the space between the elements. So what they've done is they've gone, okay, let's use Python complex numbers, because Python complex numbers have got two parts. They've got a real part and an imaginary part, and the imaginary part's got this j behind it. So if you put a number there with just a j after it, that's the complex number, and it'll go, okay, so when you're doing the imaginary part, then it means you want to do something like linspace. When you're doing the real part, it means you want to do something like a range. And so if I have a look at what's in there, then you can see that it's gave us the same values as linspace. And I just brought that up because I found that very amusing to see how they've used complex numbers in this way. But it does let us do two-dimensional grids very easily. And you can do two-dimensional grids with either one of the dimensions being in the way of a range and the other one in the way of linspace. So here's our example. Create a mesh grid, x1 having 3 values from 0 to 1 and y values from 1 to 2. And so there's mgrid. We're just going to go from 0 to 1 using 3 values, so we use the j after the 3, and 1 to 2 also with 3 values. And then we're going to flatten it all out, and there's flattening it out just basically takes a matrix and so I'll just show you what x1 looks like. So equal x1 there, so it's a array of arrays, so a two-dimensional array, so each one of those is a row. Y1 is equal to that. If you wanted to have this before it gets flattened, then it's multiplied this matrix by this matrix, and it's just well, it's actually squared that matrix first and squared this matrix and then added them together. And so that gives us a matrix, and then to flatten the matrix it just takes it row by row, and there's our data 1, 2.25, 4. Okay, Johan Lopez has said the symbol array manipulation was quite challenging, but I loved it overall. Is this an ongoing progressive set of sessions? Yeah, so we do it. I'm doing mine about every 2 weeks and coming up with different topics each time. If you want to look at some of the old topics, go to the GitHub site, and you can look at some of the old videos. But the advantage of coming to the live ones is that you can ask questions as we go along. And so sometimes I'll even repeat some of the old ones. This is our GitHub site, and you can see Arun used to do his as well, put them up on the GitHub, but he stopped doing that. But I've been doing mine, so you can look at all these old topics, and if you want to do so I think I've done one on pandas and stuff, which is a data. We've done like relational databases, and there's one you can work on relational databases. All right, now if you want to, we've been doing all this in Colab, but you can also do it in using just straight Python. So I've got Python installed on this computer. So if you wanted to run one of these exercises, I've got it as a Python script. So you see it ends in .py. The ones that end in .ipynb, that's a notebook, a Jupyter notebook, which is what Google Colab is. But the ones that end in .py, that's just a straight Python script. So we can download that raw file. And I'm going to put it into a folder. Show in folder. Is it there somewhere? It's in my downloads. I will take that file and put it into a folder for this session. Okay, so it's in the folder. And I've got Visual Studio Code, which is not my favorite, but it's a lot of people use it. And so that's opened up into the folder, Beginners Python and Machine Learning 222. And I can see my Python script. Now, if I open a terminal, I can see that I don't have a virtual environment installed. So I'm going to install a virtual environment. So Python, this is on Windows, so on others you'd say Python 3. On Windows you can say just py dash module. I want to run the virtual environment module to create a virtual environment that I'm going to call .venv. And Visual Studio Code has said, we notice a new environment has been created. Do you want to select it for this workspace folder? And I'll say yes. Okay. And now down in the bottom right hand corner you can see it's telling me which my virtual environment is. It's called .venv, and it was based on Python 3.13.5. And I'm just going to exit out of this terminal and start a new one, because that terminal didn't have the new environment. And you can see now the new environment has been activated because it's got .venv at the start. I could have activated it in the previous one, but this is another way of doing it. And now at the beginning it tells you that if you need to install some third-party libraries here into this virtual environment. So if I say pip list, it'll tell me the only thing I've got installed is pip at the moment. But if I pip install NumPy, Pandas and Plotly, it'll install those three third-party libraries plus any extra libraries that they depend on. So it's gone off to Pippy and it's downloading those libraries, it's installing them, and by putting them in the virtual environment it's not upsetting the rest of your computer anywhere. It's only going to be in this one virtual environment, which is in this one little folder here inside my project folder. So anyone else on this computer is not going to be affected by it. So it's installing all these packages, taking a while to do it. And it does cache these as well. So the second time you install them on this computer, it will into a different virtual environment. That will be quite fast. Okay. And then we can run this Python file by clicking on the play. And you can see it's opened it up, and because we're not in Google Colab, it's had to create HTML files for all our exercises. So this is the ones from before we had, and now it's actually running it. Well, it's running it as a well, it's actually serving it up on a port, which is pretty interesting. So each one of those is being served up on a different port number, and they're all the solutions to the exercises we've just had. And so if I look in here, I can see that it's created figure 1 and figure 2 because they're the only ones that we saved, and then all the others, it's actually, and I've forgotten that it did that, it's all these show commands, it's showing them by actually serving them up as a server. So that's pretty clever. Yeah, all these shows. All right. Well, that's the end of the session. Here we go. We've got another question. There is a Plotly desktop application for data analysis and visualization. Okay, I haven't used that one, so yeah, but interested to know how you go if you have used it. Often I write web applications, so I need to have a bit more control over where the Plotly charts I create show, because I want it to be a web application, like a Django application or a Flask application, and incorporate the Plotly inside it. Now you can also there's Plotly Dash, which is quite a good way of, well, it's quite a powerful way of producing charts, but it's difficult to incorporate that into your own web application. And so this is a lot of the reason for why I've talked so much about creating dictionaries and sending it to the Plotly JavaScript, is because by manually doing that, I've been able to use it into my web applications without having to try to bend Dash into what I was trying to do, because Dash is like a one-page application, and as soon as you want 2 pages, then it just became a nightmare trying to get it to work. Okay, well, any other questions? So in a couple of weeks' time, it'll be the 1st of October, so that'll be a absolute beginners session, so we'll be looking at just getting started. But I hope you enjoyed the session and learned something today, and I appreciate all the questions that I got. Thank you. Thanks, Ashok. Good stuff, Johan.